Hi everyone and welcome back to another lab. Today we are diving into the Virtual Router Redundancy Protocol or VRRP protocol, and by the end of this video you will learn what VRRP is and how it works. You will also be able to know how to configure VRRP on Cisco routers and how to verify the VRRP status and how to adjust the priorities in order for you to influence the election of the active router. You will also learn how to set a tracking object to an interface so that the VRRP decrements the priority to a lower value than that of the master router. You will also see how to configure this lab from scratch. So we will briefly walk you through what the VRRP protocol is and how it works. Then, as usual, we will go through the lab topology and lab objectives. Finally, I will cover the lab tasks and then walk you through the lab solution. So VRRP stands for Virtual Router Redundancy Protocol, and it is a network protocol that provides high availability and reliability for IP networks. VRRP enables multiple routers to work together as a virtual router to ensure that if the primary router fails, one of the backup routers can take over seamlessly. And by the way, the primary router is the master in the VRRP language. So VRRP is especially useful in scenarios where uninterrupted access to the network is critical, such as in enterprise networks or data centers. It operates by assigning a virtual IP address or VIP to a group of routers. This virtual IP address is shared among the participating routers in the VRRP group. One router is elected as the master router, which is responsible for handling traffic sent to the virtual IP. The election process is based on the priority value assigned to each router, and the router with the highest priority becomes the master. The protocol is defined by the Internet Engineering Task Force, which means you can configure it with any vendor. It operates at layer 3 of the OSI model, and it is primarily used in IP networks. And VRRP allows for a configurable priority system, enabling network administrators to designate which router should be the master under normal circumstances. The default priority is set to 100, but it can be adjusted to allow for more granular control. If a router's priority is modified, it can influence the election process during the failover scenarios. In addition to this, VRRP supports preemption, much like HSRP, and that basically allow a backup router with a higher priority to reclaim the master role once it becomes available again after a failure. This ensures that the most capable router is always handling the traffic to improve network performance. Finally, the benefits of VRRP include high availability, as multiple routers acting as a single virtual gateway, which minimize the risk of network outages due to router failure. It is also cost effective, requiring no special hardware and allowing organizations to use existing routers to implement redundancy without significant investment. Okay, so regarding the lab topology, as you can see on the screen, we have three main departments that we will use for this lab. So on the left-hand side, we have the sales department and the HR department. The sales department resides in VLAN 10, and the HR department resides in VLAN 20. PC1 is connected to access switch 1, and PC2 is connected to access switch 2. Both of these switches are then connected to the distribution switches. So access switch 2 is connected to distribution switch 1 as well as distribution switch 2. And similarly with access switch 1 is connected to distribution switch 2 and also is connected to distribution switch 1. And all the links between the access switches and the distribution switches are trunk links, and all the interfaces operate in trunk mode. Distribution switch 1 and distribution switch 2 are then connected to core router 1, and then core router 1 is connected to core router 2 via gig Ethernet 0/0, and then core router 2 is then connected to distribution switch 3 and distribution switch 4, and distribution switch 3 and distribution switch 4 are then connected to access switch 3, and then access switch 3 is connected to server A, which resides in VLAN 30, and that's part of the IT department. So as you can see on the screen, OSPF will be enabled to exchange routes between each side, and the main objectives of this lab is to provide connectivity with local network redundancy for each device. And also we will be focusing on making sure that distribution switch 1 will be the VRRP master for both departments. And similarly with the IT department, we will make sure that distribution switch 3 is also the VRRP master. So again, we have configured all end devices with the appropriate IPv4 address settings, and they are ready to go. So PC1 and PC2 and server A are good to go with regards to their configurations. Okay, so regarding the lab tasks, we will start with the configuration of access switches, which are access switch 1, access switch 2, and access switch 3 to establish connectivity for end devices and inter-switch communication. So access ports will be configured with the appropriate VLANs and set to access mode, while the trunk ports connecting to the distribution switches will be enabled with .1q encapsulation and limited to specific VLANs. Following this, in step 2, the distribution switches will be set up with similar trunk configurations to interface with access switches and each other. And then the next step, which is step number 3, involves configuring the interfaces of distribution switches and core routers with proper IPv4 address settings. These interfaces will be integrated into OSPF, which is a dynamic routing protocol to facilitate efficient routing within a single area, where we're going to use the backbone area, which is area 0. And the OSPF setup will include advertising the default gateway from the core routers to the distribution switches. And that ensures routing paths are dynamically adjusted as network conditions change. And at this point, we would have covered step 3, step 4, and step 5. We then move to step number 6. So following the OSPF configurations, we will implement VRRP on the distribution switches to provide gateway redundancy. And this involves setting up VRRP groups that match the respective VLAN IDs and assigning priorities to determine the master and backup rules for each VLAN. And again, the lab emphasizes using the preempt command to make sure that the designated master reclaims its role after recovery. And then we go to step number 7, where we are going to implement tracking objects in order to monitor the status of critical interfaces on the master distribution switches. And then we move to step number 8 to verify the effectiveness of the configurations. We will perform a series of connectivity tests, including pinging and trace routes between different devices in the network. And these tests will validate the expected paths taken by traffic under normal conditions. And then finally, we're going to do some failover tests where we are going to simulate interface failure on the distribution switch 1, and we would need to observe the changes in the VRRP status and ensure that traffic is rerouted as expected. And then after each test, the changes will be rolled back to confirm that the primary switches resume their roles. And that will be the end of our lab. Okay, so this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. So I have added the lab document in the video description so you can download it and practice at your own pace. I have also included a couple of EveEng labs for you to download. You will find the pre-lab and the post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so before I proceed with the lab solution, I'm going to pause for a moment where you can take a screenshot for the lab topology and also the lab tables where I'm about to show you. So what you see on the screen is the lab tables, where it contains IPv4 address table and access switch table, as well as the host IP address table. So feel free to take a screenshot so you can follow along with the lab. Okay, so what I'm going to do, I'm going to tackle the first task where we need to jump into access switch 1 and access switch 2 and access switch 3 and perform some access port configurations across all switches. So I'm going to open my secure CRT and I'm going to log into access switch 1 and 2 and 3. And I'm going to start with access switch 1. From there, I will start by configuring the VLAN first. So I'm going to say VLAN 10 and I'm going to name it Sales Department. And then what I'm going to do next, I'm going to go to the interface gig Ethernet 1/1. And I will set the description first. And I'm going to say link to end device, or you can say PC1 in that case. I'm going to set the switch port mode to access. And then I'm going to set the access VLAN to 10. And then I'll do the same thing on access switch 2. I'm going to create the VLAN first. So I'm going to say VLAN 20, and I'm also going to name it. I'm going to call it HR department. And then I'm going to configure interface gig Ethernet 1/1. I'll set the description. I'm going to say link to PC2. Let's set the port to access mode. And then I'm going to assign VLAN 20 to that interface. And let's jump into access switch 3 and do the same thing. So I'm going to create VLAN 30 and I'm going to name it IT department. And then I'm going to jump into interface gig Ethernet 1/1. I'll set the description to link to server A. I'm going to say switch port mode access, switch port access VLAN 30. I'm going to hit end. And then what I'm going to do next, I'm going to configure the links from access switch 1 and access switch 2 to the distribution switches. So we're going to tackle interface gig Ethernet 0/0 as well as gig Ethernet 0/1. So I'll go back to access switch 1. I'll go back to global config and I'm going to say interface range gig Ethernet 0/0 all the way to 1. I'm going to set the description. I'm going to say link to distribution switches. I'm going to set the encapsulation to .1q. So I'm going to say switch port trunk encapsulation .1q. I'm going to then set the interface to operate in trunk mode. And then I'm only going to allow VLAN 10 and VLAN 20. So I'm going to say switch port trunk allowed VLANs 10, 20. So switch 1 is done and dusted. I'm going to jump into access switch 2 and do the same thing. I'm going to say interface range gig Ethernet 0/0-1. I'm going to set the description with link to distribution switches. And again, I'm going to set the encapsulation trunk to .1q. So I'm going to say switch port trunk encapsulation .1q. And then let's force the interface to operate in trunk mode. And then allow only VLAN 10 and 20. So I'm going to say switch port trunk allowed VLAN 10 and 20. Finally, let's go to access switch 3. So I'm going to go to global config and I'm going to say interface range gig Ethernet 0/0-1. Let's set the description, link to distribution switches. Again, we're going to set the encapsulation to .1q and then force the interface to operate in trunk mode and allow only VLAN 30. So it's going to be switch port trunk allowed VLAN 30. So at this point, we have configured all access ports that connects to our end devices. We also have configured the interfaces that connect to distribution switches. So let's do some in-flight checks. So if I say show interface status, and I need to actually send the command across all devices in one go. So I'm going to up arrow that. And as you can see, I'm going to start with access switch 1. As you can see from the output here, that we have configured gig Ethernet 0/0 and 0/1. Both of these interfaces are connected to the distribution switches. They operate in trunk mode, and right now they are connected. We also can see that gig Ethernet 1/1 is connected to the end device, which is PC1, and also is part of VLAN 10. If I go to access switch 2, we have similar output where you can see gig Ethernet 0/0 and 0/1 are connected to the distribution switches. Both of these interfaces operate in trunk mode. And gig Ethernet 1/1, it is also connected to PC2. The current status is connected and is part of VLAN 20. If I go to access switch 3, we will find similar output. We get the gig Ethernet 0/0 and 0/1 interfaces that are connected to the distribution switches. The current status is connected, and also both of these interfaces operate in trunk mode. And finally, the gig Ethernet 1/1 is connected to server A and also is part of VLAN 30. We can issue another command, which is show interface trunk. So again, I'll go back to access switch 1, and here is the output. As you can see, we've got two interfaces or two trunks. So gig Ethernet 01 is using .1q, and the current status is trunk, and the native VLAN is 1. And here you can see the allowed VLANs on that trunk is only 10 and 20. But the current active one on the access switch 1 is only VLAN 10. If I go to access switch 2, we get similar output. Again, these two interfaces operate in trunk mode, and the encapsulation method is using .1q, and the allowed VLANs only 10 and 20, and the current active VLANs are only 20 on both interfaces. Finally, access switch 3, we get similar output. Gig Ethernet 01 and Gig Ethernet 00 are using .1q encapsulation, and the current status is trunk. You can see the current allowed VLANs on the trunk, on both trunks, VLAN 30, and the active VLANs is only 30. So what I'm going to do next, I'm going to jump into the distribution switches. So I'm going to close all these sessions since I don't need them anymore. So I'm going to just go ahead and close all these sessions. And then I will log into distribution switch 1, 2, and 3, and 4. So I'm going to tackle task number 2, where we need to configure all ports that connects back to the access switches with some attributes, where we need to enable trunk encapsulation. We need to force the interface to operate in trunk mode and only allow the VLANs in question. So first things first, we need to actually create VLANs. So I'm going to start by going to the global config. And then from there, I'm going to say VLAN 10. Let's name that VLAN with sales department, and then let's create VLAN 20, and I'm going to name that VLAN with HR department, and then I'm going to exit this, and I'm going to use the interface range command. I'm going to say gig Ethernet 0/0-1, and again, I'm going to set the description first. I'm going to say link to access switches. I'm going to set the encapsulation to .1q, and then I'm going to force the mode to trunk. And then I'm going to only allow VLAN 10 and 20. I will jump into distribution switch 2 and do the same thing. So I'm going to say VLAN 10, name, sales department. I'm going to go to VLAN 20, and I'm going to call this VLAN HR department, and then I'm going to issue the interface range gig Ethernet 0/0-1. I'm going to hit the description command first, where I'm going to say link to access switches. Let's set the encapsulation, and let's force the interface or the port to operate in trunk mode. And let's only allow VLANs 10 and 20. So that is done. Let's move into distribution switch 3. I'm going to go to global config, and from there I'm going to create VLAN 30. I'm going to name it IT department. I'm going to exit, and then I'm going to go to interface gig Ethernet 0/0. Let's say description, link to access switch, switch port trunk encapsulation .1q, switch port mode trunk, and then switch port trunk allowed VLANs 30. I'm going to hit end, and then I'll go to distribution switch 4 and do the same thing quickly. So I'm going to say VLAN 30, name the IT department, and I'm going to exit. I'm going to go to interface gig Ethernet 0/1. Let's set the description with link to access switch, switch port trunk encapsulation .1q, switch port mode trunk, and finally switch port trunk allowed VLANs 30. Next, we would need to configure the interlinks between each distribution switch. So I'm going to go to distribution switch 1 first, and then I'm going to go to global config again, and I'm going to say interface gig Ethernet 0/3. I'm going to say description link to distribution, or let's say this SW2. I'm going to set the encapsulation to .1q. I'm going to force the interface to trunk, and also I'm going to allow only VLANs 10 and 20. Let's do the same thing on distribution switch 2. I'll do the same thing on distribution switch 3 and 4. So I'm going to go to global config, and I'm going to say interface gig Ethernet 0/3. Let's say the description. And then finally, our distribution switch 4. And now that we have finished this step, we can move into the next step where we need to configure each interface that connects back to the core router with the appropriate IPv4 address, with the appropriate link description, and we will also need to convert the interface to operate in layer 3 instead of layer 2. So I'll go back to distribution switch 1, and I'm going to go to interface gig Ethernet 0/2, and let's set the description. I'm going to say link to C router 1, and I'm going to say no switch port. And then I'm going to set the IP address with 10.0.1.2/30. And also I'm going to enable the interface. So this switch I think is done. Let's move into the distribution switch 2 and do the same thing. Yeah, actually I have made a mistake here. I'm supposed to actually log into distribution switch 4. I'm going to fix this, but I'm going to go to distribution switch 4 first, and I'm going to go to global config, and I'm going to say interface gig Ethernet 0/2. I'm going to set the description to link to core router 2, and then I'm going to set the IP address with 10.11.2.2. I'm going to set the subnet mask, which is 255.255.255.252. And then I'm going to enable the interface. And yes, we need to actually enable layer 3 interface. So I'm going to say no switch port. And then I'm going to configure the IPv4 address. I'm also going to say no shot, just in case. And then I'm going to hit end. And then next I'm going to go to distribution switch 2. And for the sake of it, I just want to see what is the configuration under this interface. So I'm going to say do show run, let's say interface gig Ethernet 0/2. And what I'm going to do, I'm going to reset the interface to its default state. So I'm going to say default gig Ethernet 0/2. Default, oh, I need to actually exit this. Default interface. Okay. So with that being done, I can then go ahead and configure interface gig Ethernet 1/0. So I'm going to say interface gig Ethernet 1/0. Let's set the description. Say link to core router 1. I'm going to enable layer 3 capability. So I'm going to say no switch port. And then I'm going to set the IP address with 10.0.2.2 with /30 subnet mask. And also I'm going to enable the interface. Let's move into distribution switch tree. I'll go to global config. I'm going to say gig ethernet or interface gig ethernet 0/1. I'm going to set the description to link to core router 2. I'm going to say no switch port and then IP address 10.11.1.2/30. And I'm going to enable the interface. Next, we're going to configure the SVI for each distribution switch. So I'll go back to distribution switch 1, and then I'm going to say interface VLAN 10. I will set the IP address with 10.1.1.100, and the subnet mask is /24, which is 255.255.255.0. I will exit this, and I'm going to create another SVI for VLAN 20. I'm going to set the IP address with 10.2.2.100/24. And this is done. I'm going to jump into distribution switch 2 and do the same thing. So I'm going to create an SVI for VLAN 10. I'm going to set the IP address with 10.1.1.101/24. And let's do the same thing for VLAN 20. And the IP address for VLAN 20 will be 10.2.2.101/24. So this is done. Let's go and do the same thing on distribution switch 3. So I'm going to say interface VLAN 30 and the IP address is 10.3.3.100. The subnet mask is going to be /24. So it's going to be 255.255.255.0. And I'm going to hit end. And let's do the same thing on distribution switch 4. I'll say interface VLAN 30 and the IP address is 10.3.3.101. And the subnet mask is going to be 255.255.255.0. So next, what we're going to do, we're going to enable IP routing across all our distribution switches. So I'm going to just send a command to all sessions. So I will say, just first of all, let's make sure that they all in the user privilege mode. And then I'm going to say configure terminal. And I'm going to say IP routing. So that means we have configured all distribution switches with the IP routing command. So now what I'm going to do next, I'm going to actually do some in-flight checks, and I'm going to start with show interface status. And as you can see that we have these two interfaces as well as this interface that operate in trunk mode. And you can see that the only interface that is rooted interface or operate at layer 3 is gig ethernet 0/2, which is the link to core router 1. If I go to distribution switch 2, we get similar output. You can see this interface, gig ethernet 1/0, is connected to core router 1 and is also routed. These two interfaces are connected back to the access switches. They operate in trunk mode, and gig ethernet 0/3 is connected to distribution switch 1 and it operates in trunk mode as well. If I go to distribution switch 3, we can see that this is the link that interconnects between distribution switch 3 and distribution switch 4. One link that connects to the access switch, which is access switch 3, and then one link that connects to the core router 2. And you can see that this interface is also operate at layer 3. Finally, distribution switch 4, we get similar output. The only interface that is operating at layer 3 is gig ethernet 0/2, which is connected to core router 2. And the current status for all these interfaces are connected, and you can see the appropriate operational mode has been displayed. Next, I'm going to issue show interfaces trunk. Again, you can see that these two interfaces operate in trunking mode and is using .1q encapsulation and only allowing VLAN 30. Again, similar output on the distribution switch tree. And then this is the distribution switch 2. You You can see we have three interfaces, Ethernet 0/0, 0/1, and 0/3. The allowed VLANs are 10 and 20 VLANs. And the active VLANs are VLANs 10 and 20 as well. And if we look at distribution switch 1, we get similar output as well. We also can issue the show IP interface brief. And you can see here that VLAN 10 and VLAN 20, we actually forgot to enable these two interfaces. So we're going to go ahead and do that. If I go to distribution switch 2, we have the same problem here. And if I go to distribution switch 3, we also have the same thing. And then finally distribution switch 4. So let's go and fix this quickly. So I'm going to go to global config and I'm going to say interface VLAN 10. I'm going to say no shot. And then I'm going to go to VLAN 20. I'm going to say no shot. I'll go back to distribution switch 2 and do the same thing. And then do the same thing on distribution switch 3. And then distribution switch 4. Now let's repeat the same command. And I'm going to go back to distribution switch 1. You can see that these two interfaces are in the up state. And similarly with gig Ethernet 0/2, which is the interface that connects to core router 1. If I go to distribution switch 2, again, these two SVIs are in the up state and configured with the appropriate IPv4 address, as well as the gig Ethernet 1/0, which is connected back to core router 1. Let's go to distribution switch 3, and we get the SVI 30, and right now is in the up state. And the interface that connects back to core router 2 is in the up state and has the appropriate IPv4 address as well. Okay, so one last check before we proceed to the next step. Let's reveal the routing table. So I'm going to say show IP route. And as you can see from the routing table, we have three different networks which are listed in the routing table as expected. If I go to distribution switch 2, we get similar output. And distribution switch 2, we have a couple of networks which you see them in the routing table. And similarly with the distribution switch 4. Okay, so with that being done, let's move into step number 3, where we need to jump into core router 1 and core router 2 and do some basic configuration regarding IPv4 addressing first, and then we will implement some OSPF configurations. So I'll go to core router 1 and core router 2, and then I'm gonna go to user privilege mode and then go to global config. I'll say interface gig Ethernet 0/0. I'm configuring the interface that connects to core router 2. So I'm going to say the description. I'm going to say link to core router 2. Let's say the IP address with 10.10.10.1/30. Let's enable the interface. I'm also going to configure both interfaces that are connected back to the distribution switches. So I'm going to say interface gig Ethernet 0/1. Let's say link to this switch 2. I'm going to say the IP address with 10.0.2.1/30. Let's enable the interface, and then I'm going to hit exit, and then I'm going to go to interface gig Ethernet 0/2. I'm going to set the description to link to this switch 1. The IP address is going to be 10.0.1.1, and the subnet mask is 255.255.252. Going to enable the interface, and this is done for the time being. Let's go to core router 2 and do the same thing. So I'm going to go to interface gig Ethernet 0/0, which is the link that connects back to core router 1. I'm going to set the description to link to core router 1. I'm going to set the IP address with 10.10.10.2/30. Let's enable the interface. And then let's connect both interfaces that connects back to the distribution switches. So I'm going to say exit, and then I'm going to go to interface gig Ethernet 0/1. Let's set the description. It's going to say link to this switch 3. I'm going to set the IP address with 10.11.1.1/30, and I'm going to enable the interface. And then finally, I'm going to do the same thing on gig Ethernet 0/2. Let's set the description, link to this switch 4, IP address 10.11.2.1/30, and enable the interface. And now I'm going to say show IP interface brief. Let's see what is the current status. So I can see from core router 1 perspective, gig Ethernet 00 and 01 and 02 have been configured with the appropriate IPv4 address, and right now layer 1 and layer 2 are in the up state. If I go back to core router 2, we get similar output as well. So I'm going to just do some in-flight checks regarding connectivity to make sure that we have configured our network addresses correctly and appropriately and according to the lab IPv4 address table. So I'm going to say ping 10.10.10.2. That is success. I'm going to do the same thing with 10.0.2.2. That is success. I'm also going to ping 10.0.1.2. This is good. So I'm going to jump into core router 2 as well and do the same thing. So I'm going to say ping 10.11.1.2. And then finally, I'm going to say ping 10.11.2.2. And we have reachability and connectivity. Next, what I'm going to do, I'm going to configure a default route on core router 1 and core router 2. So I'll go back to core router 1. I'm going to go to global config, and then from there I'm going to say IP route 0.0.0.0, and then the destination is 0.0.0.0, and then the next hop is going to be core router 2. So it's going to be 10.10.10.2. And then I would need to do the same thing on core router 2. So with that being done, let's just verify that the default route has been taken. So I'm going to say show IP route. And you can see it is present in the routing table for core router 2 and core router 1 as well. You can see that here. Okay, so with that being done, let's move into the next step, which is step number 5, where we need to configure OSPF across core router 1, core router 2, and the distribution switches as well. So I'm going to start with core router 1, go back to global config, and I'm going to say router OSPF1. In order for us to advertise the default gateway to distribution switch 1 and distribution switch 2, we would need to use this command, which is default information originate. And then what I'm going to do next, I'm going to go to each interface and enable the OSPF process for each interface to operate in area 0. So I'm going to start with interface gig Ethernet 0/0. I'm going to say IP OSPF1 area 0. I'm going to exit. I'll go to the next interface, which is gig Ethernet 0/1, and I will issue the same command. I will exit this, and I'm going to say interface gig Ethernet 0/2, and I will issue the IP OSPF1 area 0. So that is done from core router 1 perspective. If I say show run section router, you can see that we only configured the default information originate under the router OSPF1 process or configurations. So if I say show run interface gig Ethernet 0/0, you can see that I have enabled the OSPF process under this interface. I'm going to go to core router 2 and do the same thing. So I'm going to say router OSPF2 default information originate. I'm going to hit exit, and then I'm going to say interface range gig Ethernet 0/0 all the way to 2, and I'm going to say IP OSPF2 area 0. And as you can see that we have formed a neighbor relationship between core router 1 and core router 2, as you can see here. And just to perform some in-flight checks, I'm going to say show run interface gig Ethernet 0/0. You can see that I've enabled the OSPF process under that interface. If I up arrow this and change this to 1, again, we get similar config. And then finally, gig Ethernet 0/2, we get similar output. So if I say show IP OSPF neighbor, you can see that right now we are neighboring with 10.10.10.1, which is core router 1. Okay, so with that being done, I'm going to move into distribution switch 1. And I'll do the same thing. So I'll go to global config, and then I'm going to say router OSPF1. So now that I've created the OSPF process, I can exit from the OSPF configuration level. And then I'm going to say interface VLAN 10. I'm going to say IP OSPF1 area 0. I will up arrow this. I'll do the same for interface VLAN 20. And then I'll configure the same IP OSPF1 area 0 command. And then finally, I'm going to go to interface gig Ethernet 0/2. And I'm going to say IP OSPF area 0. And as you can see that we have formed an adjacency with 10.10.10.1 on gig Ethernet 02. I will go to distribution switch 2 and do the same thing. So let's create a OSPF process ID 1. Gonna exit that, and I'm gonna say interface VLAN 10, IP OSPF 1, area 0, and let's do the same for VLAN 20, and then let's configure gig Ethernet 1/0, and I'm gonna hit end. And now you can see that we have received a syslog message that indicates that we have formed an adjacency with core router 1. So if I actually go ahead and say show IP OSPF neighbor, you can see that we are neighboring with core router 1 as well as the distribution switch 1. Next, I'm going to jump into distribution switch 3 and do the same thing. So I'm going to go to global config. I will say router OSPF2, and then I'm going to exit, and then I'm going to go to interface VLAN 30. I'm going to say IP OSPF, and the process ID is 2. I'm going to set the area to 0, and let's do the same thing for gig Ethernet 0/1, and that is done. And as you can see, we have received a syslog message indicates that we have formed an adjacency with 10.11.2.1, which is the IP address that is being assigned to core router 2. Let's go to distribution switch 4 and do the same thing. And as you can see, we have received a notification that indicates that we are an adjacent with core router 2 and distribution switch 3. So what I will do, I will execute the show IP OSPF neighbor. And if I go to distribution switch 1, we have already looked at this. If I go to distribution switch 2, you can see this is the current neighbor IDs. And if we go to distribution switch 3, you can see that we are neighboring with the core router 2 and distribution switch 4. And then finally on the distribution switch 4, we get similar output as well. So next, what I want to do, I want to actually reissue the show IP route. And if I go to distribution switch 1, you can see that the default gateway has already been populated here. So this indicates any unknown traffic would actually go via gig Ethernet 0/2, which is the interface that connects to core router 1. And if I go to distribution switch 2, we also get the same output. If I go to distribution switch 3, we also get the same output, but this time is pointing to gig Ethernet 01. And you can see that this is the next hop address, 10.11.1.1 for distribution switch 3. And if I go to distribution switch 4, we get similar output as well. Okay, so next what I'm going to do, I'm going to go to step number 6 where we need to configure VRRP across our distribution switches. So I'll go back to distribution switch 1, and from there I'm going to go to global config, And I'm going to say interface VLAN 10, and then I'm going to say VRRP 10. I'm going to set the IP address or the virtual IP address to 10.1.1.254, and I'm going to hit enter. I will set the priority to 200. And also I'm going to set the preempt command. And I'm going to do the same thing for interface VLAN 20. So I'm going to say VRRP 20, and then the IP address is going to be 10.2.2.254. I'm going to say VRRP 20, priority 200, and finally VRRP 20 and preempt. So that is done from distribution switch 1 perspective. Let's go to distribution switch 2. I'm going to say interface VLAN 10, VRRP 10, IP 10.1.1.254. And then I'm going to set the priority to 110 or 110. And that's it. I will then do the same thing for interface VLAN 20. I will say VRRP 20, IP address 10.2.2.254. I'm going to say VRRP 20, priority 110. Let's jump into distribution switch 3. I'm going to say interface VLAN 30, VRRP 30, IP address 10.3.3.254. VRRP 30, priority 200, and then finally we need to set the preemption command, which is VRRP 30, and we're going to say preempt. So that is done. Let's go to distribution switch 4 and repeat the same thing. I'm going to say interface VLAN 30, VRRP 30, IP address is 10.3.3.254, VRRP 30, and the priority is 1110. So with that being done, I'm going to actually close the Core Router 1 session and the Core Router 2 session. We don't need it right now. And in here, I'm going to say show VRRP brief. So from distribution 1 perspective, we can see that we have a couple of interfaces that are participating in VRRP process. We have VLAN 10 and VLAN 20. VLAN 10 is part of the VRRP Group 10. The current priority is set to 200. You can see right now, you can see that it's configured with preemption. And the current state indicates that this router is the master. And the master IP address is 10.1.1.100. And you can see that the group address is the virtual IP address that we configured that VRRP under. And the same thing applies for VLAN 20. The group number is 20. The priority is set to 200. And it has been configured with preemption. And the current state for this VRRP group is master. And you can see the master IP address is 10.2.2.100. And finally, the virtual IP address or the group address is 10.2.2.254. So if I go to distribution switch 2, we get similar output, but this time you can see that VLAN 10 on distribution switch 2 is part of group 10. The priority is set to 110. The current state is backup, and the master IP address is 10.1.1.100, and the virtual IP address is 10.1.254. And the same applies for VLAN 20 as well. If we go to distribution switch 3, we want to make sure that this is the master, and you can see here that this is the master for VLAN 30. You can see the current IP address for the master is 10.3.3.100, and the virtual IP address is 10.3.3.254. And then if we go to our final destination, which is distribution switch 4, you can see that we get a similar output on the screen. If you want to find out more information about VRRP, what you can do, you can actually issue the show VRRP command. And that will give you more information about each group. So for instance, if we look at the output from that command, the first line indicates the interface ID and which group is associated with. You can see the current state is master, the virtual IP as well, and also gives you information about the virtual MAC address, the advertisement interval, and whether preemption is enabled, the priority as well, or the priority value. You can see the master IP address, and it does tell you that it's local. And also it tells you the priority for the master, and then the time intervals for the advertisements and downtime interval. Okay, so what I'm going to do next, I'm going to jump into step 7, where we're going to create a tracking object that will be used to monitor the status of the interface that connects to core router 1 from the distribution switch 1 perspective. So I'm going to go to global config on distribution switch 1, and I'm going to say track, and I'm going to just, if I question mark that, you can see the content sensitive help, and I'm going to just create a tracked object ID. I'm going to say 99, and then I'm going to say interface gig ethernet 0/2. And you can see that this interface is the interface that connects to core router 1. And I'm going to say I'm interested in the line protocol. So if it changes, if the status changes, then I need to do something. And I'm going to hit enter. Then I'm going to hit exit, and then I'll go to VLAN 10, and I will say VRRP 10 track 99, which is what we just created. And here, if you question mark that, you can see that we can actually decrement the value of the priority. So we're going to say decrement by 100. So that means we know that the current priority for distribution switch 1 is set to 200. In the event of gig ethernet 02 being down, then VRRP will decrement the value from 200 to 100, which causes distribution switch 2 to be the master. And now I'm going to hit enter, and then I'm going to say exit, and I will do the same thing for VLAN 20. And then I would say VRRP 20 track 99, and I need to decrement by 100. So now let's just say show run VRRP, I think, or maybe section VRRP. And you can see this is all the configurations that we have configured for VRRP 10 and VRRP 20. So if I say show VRRP, nothing here that indicates that we are tracking an interface. But if I say show track, so you can see from the output that the track ID is 99. And here we are tracking the status of the interface gig ethernet 02. And you can see that this is being tracked by VRRP VLAN 10 and 20. So I'm going to jump into distribution switch 3 and do the same thing. So I'm going to go to global config, and I'm going to say track 99 interface gig ethernet 0/1. And we are interested in the line protocol option. I'll say exit, and then I'm going to say interface VLAN 30, VRRP 30, track 99, and we need to decrement by 100. Okay, so with that being done, I'm going to move into step number 8, where we need to perform some connectivity tests. to make sure that PC1 is able to ping PC2 as well as server A. So I'll go to PC1, and right now if I say show IP, you can see the current IP address has been set to 10.1.1.1/24. The current gateway has been set to 10.1.1.254. So technically, if I ping the gateway, I should have a response. And we do. So let's ping 10.2.2.2, which is the IP address for PC2. And we have successful ping. So I'm going to just go to PC2 as well. And I'm going to say show IP. You can see this is the IP address configurations that has been assigned to PC2. So I'm going to go back to PC1 and I'm going to issue ping 10.3.3.3, which is the IP address on server A. And we have connectivity and reachability to server A. So what I'm going to do next, I'm going to actually initiate a trace route from PC1. So I'm going to say trace 10.3.3.3. You can see that we went via distribution switch 1 because it has an IP address of 10.1.1.100. The IP address assigned to distribution switch 2 is 10.1.1.101. So this means is going via distribution switch 1 and then core router 1 and then core router 2 and then distribution switch 3 and then the final destination, which is the server A. So I'm going to do the same thing on PC2. So I'm going to say ping 10.3.3.3. So we have reachability to server A from PC2. Let's also perform a trace. We also have successful trace. And you can see that we are still going via distribution switch 1. Okay, so what I'm going to do, I'm going to perform a failover test. And this step is step number 9, by the way. So I'm going to go to PC1 and I'm going to move it into another view. So you can see it from the right-hand side here. And then I'm going to go to distribution switch 1. And what I'll do, I'll go to global config. And I'm going to go to interface VLAN 10. And basically what I'm doing, I'm shutting down the gateway or the interface VLAN 10. So I'm going to go to the interface config level. And from there, I'm going to say shut down. But before I do that, what I'm going to do, I'm going to actually initiate a continuous ping. So I'm going to say ping 10.3.3.3. And let's set the count to 100. And here I'm going to shut down the interface. And as you can see that we have lost a few packets in here. However, if I issue trace 10.3.3.3, this time that you can see we are going via distribution switch 2. So I would say that the first test is passed since we have managed to fall back to distribution switch 2. And what I'm going to do, I'm going to go back to distribution switch 2 in here and I'm going to say show VRRP brief. And if I just expand the output and up arrow this to execute the command again, you can see that the VLAN 10 is the master on distribution switch 2 since we shut down interface VLAN 10. You can see the current state is the master. And if I go to distribution switch 1 and say do show VRRP, let's actually issue the brief to make it simple. You can see it's in the init state, which is not the backup and is not the master. Okay, so what I'm going to do, I'm going to actually unshut the interface. So I'm going to say no shut. And in the meantime, I'm going to say ping 10.3.3.3, and I'm going to say count to 100. And on the left hand side, I'm going to enable the interface and let's see what happens. So I'm going to cancel this. And if I up arrow multiple times to get to the trace command, you can see that now we are going back to distribution switch 1, which is 10.1.1.100. And that's what is expected. So next what I'm going to do, I'm going to go to interface gig Ethernet 0/2 and I will shut down that interface. And remember, this interface is the link between distribution switch 1 and core router 1. So let's say hypothetically that link goes down. How would VRRP be aware of such a thing? That's why we need to use a tracking object to alert VRRP that the status has changed from up to down, and then therefore it will decrement the priority value to 100, which is going to be lower than 110, and that would trigger distribution switch 2 to take over from distribution switch 1. So again, I'm going to go back here and I'm going to initiate the ping 10.3.3.3, and I'm going to set the number of counts to 100. And on the left hand side, I'm going to say shut down. So you can see instantly that VLAN 10 and VLAN 20 are out of the game because the current status for VRRP is changed from master to backup, as you can see from the screen here. And the ping was successful. We only lost a couple of packets. So I'm going to cancel this and I'm going to actually say do show VRRP brief. And you can see that both of these VRRP groups are in the backup state and the current priority is set to 100. And if I go back to distribution switch 2, issue show VRRP brief, you can see that the current priority is 110. And because of that, distribution switch 2 has a higher priority than distribution switch 1, and therefore it is the master for both VRRP groups. So if I go back to PC1 and issue the trace command, you would see that we are going via 10.1.1.101, which is the IP address associated to distribution switch 2. So I'm going to go back and roll back the changes. So I'll say no shot. And before I do that, I'm just going to initiate the ping again. And now you can see that distribution switch 1 has become the master once more. So if I hit end and say show VRRP brief, you can see that now we are the master. And at this point, we can go ahead and save our configurations, and we have reached the end of our lab. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.